Okay, so today we're going to talk about minerals. Before we start, we're going to a few reminders. Pause and rewind whenever you need to. Look out for test question alerts and make sure you write down all vocabulary that's highlighted. So we started class today with the rules of being a rock. So what it would take to be a mineral. So we said you had to be naturally occurring, which means you had to form by a process that happens naturally. You had to be solid, so liquids and gases. I'm sorry, that doesn't work. You had to have a crystal structure, which means there had to be a pattern. And you had to be formed by inorganic process. So when I talked about putting the drinking water in the freezer, that was not an inorganic process, or it was not naturally formed, so it couldn't have been a mineral. And then it has to have a definite chemical composition with a definite formula. So minerals form in three ways. The first way is through solutions. And a solution is a mixture in which one substance is dissolved in another. So this is basically called crystallization. And we're actually going to do this in class either at the end of this week or the beginning of next week. They also form from magma and lava. So when magma cools, it hardens and it forms minerals. The last way is kind of an exception to the rules we've talked about today, in that it can also form through an organic process. So materials such as calcite can cement together. Calcite is calcium carbonate, which has the formula CaCO3. Now, this is carbon, and we said in class today that carbon could not make up a mineral because it's organic. Well, the carbon in this case doesn't matter because the process that was used to form it was inorganic and was a natural process. Cementation is just basically pressure forming a rock or a mineral. So, we identify minerals using several properties. The first one is obviously color, whether it's red, blue, green, indigo, violet, chartreuse, maroon. Then we have streak. And streak is the color of the powder when rubbed on a plate. Usually the plate is either made of ceramic or it's made of glass. And sometimes the streak is different from the color of the rock. In this case, pyrite, which is gold, but it has a green streak. And that's kind of how you can tell them apart from real gold, is that the streak of gold is gold and the streak of pyrite is green. Then we have luster, and that's how shiny something is or how light is reflected from a mineral's surface. So it can have three different types. You can have metallic luster, which means it looks like it's metal. It could have glassy luster, which means it looks like it's glass. Or it could have silky luster, which is basically, it's just kind of dull. Hardness is a really important property for us to identify minerals with. And we use what's called the Mohs hardness scale. And it's used to rank the hardness of minerals. Basically, we perform what's called a scratch test. And any mineral can scratch anything that's softer than itself. So if we have quartz can scratch anything underneath it on the hardness scale. So it can scratch talc, it can scratch gypsum, it can scratch calcite, but it cannot scratch topaz. But topaz can scratch quartz. We also use these as kind of also things to meet in the middle. So we have a drill bit, which is usually 8.5, a nail, which is 6.5, copper penny is 3.5, and your fingernail is usually around 2.5. So your fingernail can actually scratch gypsum and talc. And we're going to use this when we identify minerals in class. And if you find a mineral that's not on the scale, you can use the scale to figure out what it will scratch and what it won't. And this will tell you the mineral's hardness. We talked about how minerals always had to have a crystal structure. It's actually one of the properties we use. So it's the atoms that make it up are in a regular pattern. Different minerals have different crystal structures that are different. So calcite is cubic. I showed some of you emerald, it's called octagonal. It basically looks like a diamond. And then we have mica, which is basically what's called lateral, or you can just peel it off in sheets. Mica's right here. This is a picture of mica here. So another property we use is cleavage and fracture. Cleavage is a mineral's ability to split evenly along flat surfaces. So when you break it, it forms a flat surface. If that happens, it's said that the mineral has cleavage. Fracture is when a mineral does not split evenly. So think about if you've ever seen a geode, which has those crystals in it, and I showed you one of those in class as well today. When you hit it with a hammer, it kind of doesn't split evenly. It just kind of opens up and you find the crystals inside. A good example of that is mica, which I showed you here. Some minerals have special properties. So calcite has a reaction with hydrochloric acid that actually fizzes and bubbles. Halite tastes like salt. It actually is salt. It's sodium chloride. You may not taste halite in the lab, so don't ask me. Other minerals, like we talked about in class, glow. So here we have biotite. And this actually, under the right amount of lights, will actually glow. And then magnetite, which is this, is actually magnetic. And that's all I have for you today.